We started discussing satellite communication as an example of LOS communication,
Yes, sir.
and we've been sharing information related to its deployment. And please don't ignore the basic information. We uh, uh, discuss the, I mean, sometimes we discuss how things are, how, what the, I mean, technical way to deploy something, okay, or you have, what are the basic components you have. And sometimes we discuss how it is deployed commercially, or the commercial status of different applications, because both types of information is required. Okay, you yesterday one of, I mean, an alumni student called me, and he had a job in one, in a mobile company before, and recently he moved to another telecom related government job, and he told me that the courseworks with me helped him facing the interviews a, a lot. Okay. And so, I mean, just after getting the new appointment letter, he first called me, okay, to actually basically express this fact. So anyway, inshallah, this information will be helpful in future. Okay, so let's
Inshallah.
begin. Okay, I think we didn't go far in this discussion.
No, so we just
Basically,
started.
yeah, right. We just discussed the geo satellite has a particular altitude, and we're not showing the calculation, but it is easy. Any of you can do it. Just if you just the centrifugal force, and I mean, because of the rotation will be equal to the centripetal force, which is due to the gravitation. Okay, so if you just assume m for the mass of your satellite, and then do the calculation, m will be cancelled and the mass of the earth is known. Okay, so you can find out the particular radius that you need, okay, to have a rotation period. Okay, I mean, you need a particular velocity there, so that the rotation period becomes equal to 24 hours, okay, or the exact duration of the date. Okay, so I mean, for that rotation, particular rotation period, the radius will have a particular value, okay, and it will be close to this value, okay, around 22,000 miles. So we have a fixed position on the sky, and the Earth station doesn't have to rotate. No, oh, we actually started discussing this thing. I now remember.
Yes, with
Yeah,
this diagram, sir, so
yeah,
that we'll
right,
start from here
right,
again. Yes.
right. And at the Earth station, first you, um, I mean, in this example, we are sending signal from the Earth station, and the satellite is sort of relaying the signal. Okay, it is receiving and sending it back to the Earth, and at another Earth station, we are receiving the signal. Okay, so that's how the example explains, and it's The operation for TV station works this way. So when you send the signal from the earth station, of course you use a power amplifier with good capacity, because you, in satellite communication, in this example we have the largest path loss. Okay, I mean satellite is far away. uh, and anyway, for any applications, when you are at the last stage for transmission, okay, I mean you send the signal to the antenna, then you have a power amplifier, the last stage of your whole circuit. This part is called RF front end. The part of the circuit that we can see now is the last stage of transmission, right? I mean, it is the stage next to the antenna. This part is called RF front end. Similarly, when you receive, right after your reception, or the part next to the antenna, it is RF front end. Well, what part of the circuit will be RF front end? Okay, until you have uh, you down convert to the ordinary frequency. Okay, so these are, I mean, this part is showing operation at the high frequency, so we can see now the RF front end part of the circuit. Okay, so it is separately treated because for high frequencies, uh, the circuit operation techniques are different. The circuit components have different types. Okay, and these things we basically cover in the microwave engineering course. Okay, by yeah, I should mention that how you separate between these high frequencies and low frequency operation. I'm saying that I also mentioned it before, that you need a different methods for circuit calculations, and the circuit components, okay, will also be of different kind for high frequencies. By when you realize that you have got to that high frequencies, it's actually the order of gigahertz. Okay, when it is in the order of gigahertz, then you need this different type of methods or circuit components. Okay, so after you transmit from the earth station, we are here last time, you receive it at the satellite, and at the receiving circuit, you need a low noise amplifier. Okay, uh, and then I mean, in this example we have an analog processing. I mean, uh, you are not converting into original signal. The same signal is just given a different frequency for downlink operation. We know that for downlink it will be a lower frequency. Okay. So in the uplink you have received the signal, the same signal bandwidth will be just translated to another carrier frequency for downlink transmission, and it is fed to an amplifier. Again, it is a low noise type of amplifier. Now this component is called transponder on satellite. The term transponder is used for satellite. Okay, and you this whole circuit part, okay, uh, is used on satellite, and it is I mean, this term, transponder term, is specific to satellite applications. Okay. So it is attached to a satellite, and it's a combination of the transmitter and uh, basically, I mean, a receiver plus transmitter. Okay, altogether you have. So it receives and then transmits at the suggested frequency. Okay. Okay, and then at the earth station you again receive and use an LNA. Uh, and if you had a digital um, signal, I mean, you recover the original digital signal and then again you transmit. Okay, then you can again use a high power amplifier here. Okay, you recover your signal and then you can again use a power amplifier with good capacity. Yeah. No, at the earth station you have a local oscillator we see, and it uses that super heterodyne method of uh, method for amplification. So an intermediate amplifier, IF amplifier, will work here, which has a narrower bandwidth. Okay, the amplifier at the early stage has a wide bandwidth, but after this mixing operation, it is converted to a small bandwidth. Okay, and so you can use IF amplifier. Okay. So this is why I covered that super heterodyne principle right before presenting this satellite. Okay. So this just what I have explained. Well, OPBO gives you how much uh, you are lower from your maximum level. Okay. Uh, so if the maximum level is 40 dBm, okay, I mean maximum capacity of the power amplifier is for 40 dBm, and you are operating at 34 dBm, then your OPBO is 6 dB. Okay. So you, I mean, you may mention it for your earth station or for transponders. Okay, the transponder is operating at this much OPBO, or the earth station is operating at this much OPBO. Okay. So now we will show you a I mean equation for the received power, and in this case the basic equation is very simple. We have an LOS communication with no second component at the receiving end. Okay, it cannot have two-ray model. You cannot have a secondary reflected from anywhere. I mean, there is no way to have a second component of your signal. So just a direct LOS link. So you actually need to use free space equation, which is the simplest form for all of our wireless links. And that's why the PR will be just EIR P plus GR minus LP, where LP is 20 log 4 pi R by lambda. Okay, you know, it is simple. However, there can be few other small loss components, like the losses due to the atmosphere. Okay, I mean atmospheric effects like some absorption of energy by the air or water vapor or rain. Rain can be a significant component here. Okay. um, if it rains heavily, then it can offer severe attenuation. Severe attenuation. The raindrops can absorb a lot of energy. Okay. Uh, I mean, it almost works like a curtain on the way when it rains heavily. Okay. Uh, so also you can have some losses at the antenna at each side of the gain. Well, uh, I mean, some okay, merely some antenna losses. In the third point, you may have some reduction in gain due to the antenna misalignment. Okay. Since you are using very narrow beam and you try to pinpoint, okay, so if there is even slight misalignment, you can have a significant reduction in the antenna gain. So including all these components, the whole equation will be like this. Okay, you just incorporate all these types of attenuation due to polarization. If you have some polarization misalignment,
So are these
point,
all in logarithmic
yeah,
term?
yeah, yeah, right.
Okay.
They are all in dB.
Okay.
They're all in dB. You know, the EIRP term we show in dBm. Okay,
Okay.
and on the left side the PR is shown in dBm. The rest of the components are shown in dB. Okay, because if you have the basic ratios, okay, the general terms not in dB, then you uh, you divided both sides by 1 milliwatt. Okay, so one component on the right side will have 1 milliwatt in the denominator. Okay, and you can you put it, I mean, it is convention that you use it with the power component. Okay, we have here PG or EIRP together. So below that you should have 1 milliwatt. So only this EIRP component will have dBm. The rest of the components have dB.
So sir, since
Yeah,
EIRP is in dBm, PR will also be in dBm.
dBm definitely.
Yes.
Okay. Now let me tell you that this rain component, okay, I say that can have severe effect, and the way it is handled, that if when it rains heavily, then from the transmitting end, a power boost is used. Okay, you check, maybe you boost the power transmit power level by 3 dB or even 6 dB. Okay, depending on how much it is raining on the way. Okay. So it is taken care of, changing the power level. And you know that you might have been operating with some OPBO 6 dB. Okay, and you usually operate at this OPBO, but you have this reserved OPBO because to take care of the rain cases. When it rains, then you operate at the maximum power level, 40 dBm. So otherwise, when it does not rain, you use the 6 dB OPBO. So things work like that. So I mean, raindrops at non-ordinary frequencies don't hamper that much, but in higher micro frequencies, rain is a severe problem because the raindrop and the wavelength has similar dimension. The I mean, both are in the order of centimeters. Now let us talk about our satellite. We now own a satellite, and I'd say it has been a good initiative from the government, although technically it has been taken care of by foreigners. It, it was built by other countries, it was launched by other countries, and has been managed basically by foreign people. But uh, in the operation, uh, I mean, it is operated now from our country. The earth stations are located in our countries, and they are operated here, and our local people are working at this operation ends. And at least we have some participation, and we got some exposure. We are it has been a source of our improvement, or we now have a, roadmap for technical advancement. About commercial benefit, it is still not sure whether we can make profit or not. Okay, but it is not a, it will not be really a loss project. Okay, maybe we can reach the break even at the, I mean, eventually, or we may make a small profit. Okay, or if it, in the worst case, if there is some loss, then the loss will be insignificant. So uh, it is, I mean, commercially, it is, it has been a viable project, or uh, the planning was I would say a good decision. Okay.
So what is the main source of income through the satellite communication
The satellite TV.
of
Yeah,
this channel?
actually, we'll be discussing that in the next slides. But that is,
Okay.
the answer is satellite TVs, the TV broadcast.
Okay. Akash, so sir, that is why
Yeah,
Akash is advertised so much, sir. I
yeah,
understand.
yeah.
Okay, sir.
So anyway, this BS Bangabandhu satellite one is a geo satellite. It was launched in 2018, and it has a 15-year expected lifetime. The satellite is, every satellite has usually has this kind of lifetime. Okay, it's a satellite cannot work for a too long period. And there are two earth stations, one at Jadavpur and the other at Bedbunia. And the cost is a little higher than 2,700 crores. Okay, the total maybe may have gone close to 3,000 crore. The coverage area is Bangladesh and countries around us, uh, part of Bay of Bengal, India, Nepal, Bhutan, Sri Lanka, Philippines, Indonesia. And it has 40 transponders, 26 in Ku band, 14 in C band. These bands I probably showed you before. For high frequencies, separately these bands are defined. And the very early satellites were all built for operation in C band. The first satellites, okay, the first age of satellites had operation only in the C band. Later, people realized that I mean, the C band got it started to get full, and people felt that we need to occupy new bands. So they went for Ku band, and now Ka band. There's another band with even higher frequency. Ka band has also operation for many satellites. So anyway, our sub operation in C and Ku band. Each transponder has a bandwidth of 36 megahertz, and the total bandwidth is roughly 1600 megahertz. Currently, we have 36 satellite TV channels, okay, other than Akash, including both private channels and government-owned channels.
Okay, sir.
There are 36, and the whole list you can find here at the link shown. And Spice TV is the last one which joined. Um, and Spice TV probably is not yet available in operation. Okay, they're yet to start the operation, but um, they have already joined. Okay, because they have joined actually very recently, so probably they are yet to begin their operation. Akash is the first local direct to home provider. Okay, you can use, you know how Akash operates. Probably all of you know. You have a small antenna and a small equipment, okay, that you get from this Akash operator. Beximco is actually the owner of this Akash operation. Uh, so with that, from anywhere in the country, you can get the service of Akash. Your antenna just have to direct it properly, direct towards our Bangabandhu satellite. Okay. So from anywhere in the country, you can get the service. And For other TV channels, uh, people, I mean, there are uh, some satellite service providers which provide service in your locality. Okay, basically some VSAT
Yes, sir.
will collect the signal, and then they can provide it through wired service. Okay. And you can get this TV channel service using this wired connection. But in the case of Akash, you don't need wired connection. That's the beauty. So you can, if you, for example, want to, in the Eid vacation, you're going to your village, okay, you can take Akash service, the antenna and all that. You can take there, and
Yes,
you
sir.
can get the service over there. For this type, it's not possible because you are using the connection, using the service, using wired connections. Okay,
Yes, sir.
so that is the main advantage here. And Akash transmits 120 TV channels in total, but it depends on the package, which package is used. Okay, how much you pay for your package. They have different packages like light plus, standard, different packages they have. Okay, but in total they have the capabilities. They support 120 TV channels, and they have rented 5 transponders uh, from the government. Out of 120 TV, they have, I mean, little more than 40 use HD channels. HD, I mean, these things are, I'm not much into this video encoding techniques, and we won't discuss it in detail, but I mean, I uh, looked into these things sometimes back, but uh, I don't have much interest in this part. So there are basically two types of techniques. Okay, uh, in practice, uh, the standard definition and high definition for TV. I mean, probably you know better than I do. Okay. So the HD uses MPEG 2 and HD uses MPEG 4. The audio part is the same for both, but the video capturing, okay, uh, how much information you capture has a difference. And The HD has almost twice as much as data rate. Okay, it depends how you capture. For both SD and HD, uh, the encoders don't have a fixed data rate. Rather, it depends. Okay, different implementations uh, work differently with different levels of quality. For SD, the bit rate can be as low as 4 Mbps, and it can be as it roughly 4 to 10 okay Mbps. But for HD, it can go up to 15 okay Mbps. Anyway, but that whole depends on how you capture. There are different other things involved here in picture capturing, different techniques. So we are not discussing this part. Uh, the reason I'm telling you that we have mentioned that some TV channels use HD and some some use SD. It is also true here. If you go to this link, you can check which TV channels transmit HD and which use SD. Of course, HD TV channels pay more as they use wider bandwidth. Okay, compared to SD, HD TV channels use wider bandwidth, and so they have to pay more. So from the list, you can actually before watching a TV channel, you can check which would have better picture quality.
So like
Because
GTV, sir. GTV is HD.
okay,
Yes, sir.
okay. So you can actually check. I mean, beforehand, you can come to know which would have the better picture quality. Other than this satellite TV channel, TV services, uh, we are yet to get enough. I mean, we are yet to get other type of service. I mean, some services. Okay, uh, some ATM booths, only a few, 4 or 5 ATM booths of Das Bangla banks and in Eastern banks have got connection using. I mean, in remote areas, okay, they have used the satellite connection. But it was expected that we would have internet connection in remote areas using Bangabandhu satellite, but there hasn't been much progress. Okay. We would have, say, telemedicine or many different types of service in rural areas, but there hasn't been much progress in this part. Okay. Uh, However, you I mean, there are some well, see, uh, the service of Akash, okay, can also be available on vessels. You know, this
Yes, sir.
yeah, it's possible. Anyway, so we have a lot of bandwidth of BS1 still unsold. Okay, I mean, a lot of transponders are there which are not providing any service.
Sir, how many transponders are
We
there in
we,
total?
we have 40.
Okay.
It has 40 in total.
Okay.
Okay, so it's a quick summary of how much we are earning. Okay. So currently it is roughly 125 crores annually, and basically from satellite TV channels. Okay, I mean, essentially from satellite TV channels. The revenue from other sources are negligible. From Akash, we earn close to 10 crores annually out of 125. From Akash, it is roughly 10 crores. So in dollars, it is like $90,000 a month. Okay. And unfortunately, the whole bandwidth is sold only in our local market. So all the uh, local TV operators, local satellite TV operators. Now, however, uh, it can be a piece of good news that all the local satellite TV operators now are now using BS1. Okay. Before the launching of BS1, they used to use, the foreign satellites, and they had to pay four to $5,000 a month for their operation. Okay. Every TV channel used to pay $5,000 a month. But now, BS1 offers cheaper rate. Okay, so they all have moved to BS1. But we could not have a good price negotiation for operation in other countries. Okay, it could not yet be rented out of the country. Their asking prices were lower than what our government offered. Okay. However, I just expect that in future, some vendors, instead of leaving these transponders idle, okay, it is better that you sell at lower price. And government has already hinted that they might reduce the price for the foreigners. So probably our revenue will improve, and we may eventually, this whole project may see some profit. Now, with this kind of uh, annual profit, it is uh, we are not really it may turn out to be a uh, lost project. Okay, so um, initially the anticipation when government was launching in different occasions, they are saying that almost in the half of the life period the investment would be recovered. Okay, anyway,
It is the same government that gave away free underground cable.
no, no, it's not the same
No,
government.
it's not
It's
the
not the
same
same.
government.
It's not
No,
the
it's
same
not.
government. It's
Okay.
not the same government.
Okay.
Okay.
All right.
Okay. I'd say, this government is more technical. Technically, at least a little better. No, I'm not biased to any government,
Yes,
but
sir. Yes,
just
sir.
my technical observation is like that.
Yes.
Okay. Now, the government also projects launching Bangabandhu Satellite 2 and also Bangabandhu Satellite 3. BS2 will hopefully be launched in 2023. See, this is what we have so far, and it hasn't been it has been only 3 years. Like, so, it may happen that we'll be able to. There are a lot of satellite TV operating outside our country, and we are covering those countries. Okay, so if they rent from us, it is very much possible. Okay, so it's only about price negotiation. So I think the government can settle it more logically, and they can go for uh, actually better revenue. Okay, so I just hope that it will happen. It seems that government has already realized these facts. Um, okay, and now it may sound little surprising why we need Bangabandhu Satellite 2 or Bangabandhu Satellite 3. But let me tell you, I also agree on this planning, because things will be, the requirements are changing. Okay, and BS1 has a has only 15 years lifetime. Okay, and we expect that there will be a lot more operation. Okay, so we will be growing in this area, so we'll be able to capture more market. um, so the vision, I mean, the vision should be wide. Okay, and so I personally agree. Now we will we'll discuss an example of satellite-based service, GPS. Okay, we'll discuss two example services, GPS and satellite-based phones. First, GPS. Uh, G we all know what it does. It gives us the position information and also the time information. Okay, probably you know that it gives also time information. Okay. So anywhere from anywhere in the world, if you with the GPS receiver, if you can capture the GPS signal, then you can get both position and time information, even if you are climbing a mountain or you are in the deep sea. So it is owned by United States government and operated by their Air Force. Um, there is a Air Force base in Colorado. I actually went there uh, in front of this Force base. So it has the master control station. Initially, they started this operation with a view to serve only their army. Okay. The first planning targeted helping their army only. But later they thought that, okay, I mean, once they start deployed it successfully, they uh, wanted to go for commercial service too. It's not commercial, that they don't operate it that commercially. Okay, you get the service for free. However, the precision level has always been different for their, I mean, the army, US Army does not use this publicly available GPS. Their GPS has always been different. The GPS service they use has always been different. And I mean, their service is encoded. Okay, I mean, you cannot access. And that has much precision level always. Okay. When they started the operation, the precision level was 10 times higher for their own army in the GPS. Okay, I mean, between the publicly available GPS and GPS for US Army, the precision level was this much different, 10 times better. Uh, GPS satellites use satellites at the medium Earth orbit. I'll tell you why. Okay, so the altitude is approximately 20,000 kilometer. Now, in this case, you need to have 4 GPS satellites at least to be visible. By visible, I mean you need signal from at least 4 GPS satellites. Okay, but why you need 4? Well, uh, from a particular position. Well, if I draw a 2D graph, okay, and I put 3 dots there, okay, on the 2D graph. For 2 of the 3, I give you the coordinate positions x1, y1, x2, y2. And then I also give you the distance between distance of the third point from these 2 positions. Okay. I mean, distance between the first and the third point, and the second of the second and the third point. Okay. Then you know that you can determine the position of the third point, right?
Yes, sir.
Right? You know.
Yes.
So in the 2D graph, in the 2D plane, you can determine the position when you know the distance from two known positions. Okay. So in 3D space, to be able to determine your position, what you need to know the distance from three known positions, right? Then you should be able to solve the equation. It's easy to solve the equation. Okay, and um, you can get your own position, right? So that's how it works. But it also, you have actually a fourth unknown in your equation, and that's time. So it's x1, y1, z1, and t. Okay, so four unknowns in your equation, and that's why you actually need to know the need to have information from four different positions. Okay, now uh, these things are, I mean, we won't discuss in detail, but just I'm just touching upon this fact that they all transmit some um, coded signals, and from your end, using correlation, you can find out. I mean, these are some, these codings are these things we discuss in the beginning of cellular communication course when we cover the CDMA fundamentals. Okay, in the beginning of the cellular communication course, we explain how CDMA basically works in 3G. So using correlation, you can determine, I mean, you use some particular sequence of bits, some fixed sequence of bits. This whole sequence is long, and this either you send this sequence or a particular bit pattern is processed with these bits. Okay, it's called a scrambling operation with this chip sequence. Now, at the receiving end, you can using correlation, you can determine where the whole sequence is located. The sequence will arrive at the receiver one after another. You're receiving the signal, so it's a bit stream. So you are receiving the bits in the sequence one after another. So using correlation, you can find out where the actual whole sequence, where the sequence starts, where it ends, okay, which position you are receiving right now. So this way you can. Now, when you have a synchronized transmission, okay, I mean, or you have a particular timing for the transmission of the signal, okay. At the receiving end, you also have particular uh, time information. I mean, I mean, it depends on the distance, it depends on the propagation delay of the signal, where you should receive which position in the sequence. So all all of them depend on the depend on the distances, and this is the fundamental way to find out the position. Okay. So they use basically this coding of the signal. So at least from four GPS satellites, you need to receive signal. Okay, then would be able to determine GPS position. Sometimes, if you are far inside building, your GPS may not work far inside a building. So the GPS, you may lose it, but when you lose, you you may still be receiving signal from 3 GPS satellites, but not 4. Okay, but not 4. So when it uh, falls below 4, then your GPS receiver can no longer work. Okay. Now, in practice, I mean, in the sky, 5 to 8 uh, in practice, 6 to 8 GPS satellites remain visible. Okay, so 4 is enough, but more than 4 is accommodated. Okay, so all GPS satellites help you equally. I mean, they provide you the information. Um, I mean, their positions are actually known, and the distances are known. I mean, this is the basic technique for the calculation, but they do their calculation in their own ways. Okay, but this is the uh, basic uh, I mean technique, I would say, or what. Anyway, so six. So the number of satellites, okay, are actually many, and now 30, okay, in total. But they are made available at medium Earth orbit, because in this case you have to have a wide um, beam radiation pattern at the receiving end. You need to receive signal from satellites in different directions at a time. From 4, 5, or 6 satellites, you are receiving signals. Okay, and they are located in different directions. So you need a very wide radiation pattern, meaning that the antenna gain of your receiver will be poor. Okay, so to ensure that you have sufficient signal power reception, the signal power level has to be pretty good. And that means that the path loss should not be too much. Okay, if the path loss is too large, then the energy level in the air will be too small. You already have poor antenna gain. Okay, so your receipt power will be very low. And to ensure that the path loss is not too uh, uh, it's not too large, the satellites fly at a pretty low level, okay, to around 20,000 kilometer. Okay, with this distance, the signal level is manageable. Also, the number of satellites that you wanna use to cover the whole surface of the world matters. Okay. You need to have these many satellites visible. So how many satellites actually you need to cover the whole surface of the world? Okay, so considering all these things, this type of height has been chosen. Okay, the United States is committed to maintaining the availability of at least 24 GPS satellites. Okay, but oh, I'm sorry, I have been little mistaken. I wanted to write here 30. Oh, sorry. Currently, there are 30. Previously, there were 31. Previously, there were 31, but currently they have 30 satellites. Okay, I mean it is around 30. There, I should have written here, has been flying around 30 GPS satellites. Okay. But if they flew 24, it would be enough for the for covering the whole world. The GPS satellites, you know that it started operating in 1995, right? 95. And since then, the satellites had few generations. Okay, like the Block 1 satellites were first launched, and you know that the lifespan of the satellite is not too long. So currently there are no Block 1 satellites. Later, they started launching Block 2 satellites, and uh, finally they started launching Block 3 satellites. And these are also called next generation. The service based on these Block 3 satellites are also is called next generation GPS. So currently there is no Block 1 satellites, and there are 26. Basically, the GPS is using the Block 2, the services of Block 2 satellites. 26 Block 2 satellites are operational, and we have 4 Block 3 satellites operational. Okay, no, sorry, 5. That's a little mistaken in writing. 5 Block 3 satellites have been launched so far. It's not 3 in the parentheses. It should be 5 3 Block 3. I'll correct it now before uploading. So the satellites I have for Block 3 satellites, uh, they are again split into 2 parts. So far only the Block 3A type of satellites have been launched, and 5 Block 3A satellites have been launched so far, as you can see. Okay, and the previous slide I was mistaken, and one of them is in the stage of testing. So 4 of them are operational, and there are 10 satellites in Block 3. So the launching of this Block 3A should complete in 2023. Okay, and the whole the launching of all Block 3 satellites should complete by 2034. There will be 22 satellites in Block 3F part. Okay. So that should complete by 2034. And there will no longer be any GPS-2 satellites by then. All Block 2 satellites will become obsolete by 2034. Okay, so from 2034, the service will be completely based on GPS-3. Now, in the case of GPS-2, there wasn't much improvement in the quality of service. I mean, a little bit change was there, but for GPS-3 satellites, this quality of service should be much better. First, the accuracy level, that's most important. It will be 3 times more accurate. At present, it is 5 to 10 meters accuracy. We have 5 to 10 meters accuracy, but with GPS-3, there will be accuracy from 1 to 3 meters. And the lifespan is larger for these GPS-3 satellites. Previously, it was 7.5 years, but these GPS satellites will have 12 years lifespan. The power will be higher, okay, to ensure that you can receive signal even you have, if you have some shadowing effect, okay, some obstacles around, uh, and also it should be more jam resistance. Okay, I mean, if some evil doers create some jamming signal, then to cause phase failure in GPS operation, okay, the coding techniques they use, the GPS 3 is more jam resistance. Okay, so it's all about better coding techniques. Okay, so these are the advantages with the upcoming GPS service. Questions?
None, sir. It's okay.
Okay, then we will discuss another satellite-based service, satellite-based phones. Okay, now we have cellular phones using cellular base stations, but it could be actually it was all, an understanding before, even in uh, I mean, there was a the first project was launched long ago to have some satellite-based phones. The advantage with satellite-based phones are that you don't have to build so many base stations. From satellite, your coverage area is large. So the whole project can be eventually cheaper. You can support all the different users and the service availability will be better. With terrestrial base stations, you there are sometimes there are some coverage holes. Okay, you direct your antennas in different directions. You set up another base station in the neighborhood, and some area may not get good signal. But from a satellite located up above, when you face towards the world, you can actually cover more reliably all the areas you can cover. And uh, I mean, uh, it there can be in some views, okay, I mean, things could be better, but in practice there are satellite phones, satellite based phones, or they are called satellite phone or sat phone, but their services are very limited in the world. Okay, uh, there are a few operators, but they have limited number of customers, they have limited operation. Can you tell me why it is like that? We know that the the terrestrial cellular operation has been so popular. Okay, commercially, it has been uh, one of the most successful projects in this century. So, can you tell me why uh, the satellite-based service couldn't have this type of commercial success?
Is it because of the large scale implementation?
Sir, can a satellite connection be from one side of the earth to
The
another?
other,
Sorry.
So can a satellite connection be from one side of the earth to another? It should face only one way, right?
But you can just like with GPS, you are covering the whole world. Any point on the world is covered by GPS satellites. You just set up as many satellites as you need, right? Actually, the earliest project for satellite phones were launched by Motorola. Okay, Iridium. That Iridium is there is still an operation with Iridium term, but I mean they left that project. So in that project, they wanted to launch 66 satellites. 66 or 77. I think 66 satellites. Okay, covering the whole world. So what's the
Is this
problem?
costly, sir? Is
No,
this
it is not. It is
it's
not.
not?
Eventually, it is not,
Okay.
because you compare it with covering the whole world using base stations,
Okay.
right? Compare that cost, then you will find that it is much cheaper.
So is it
The
due to
loss.
latency?
Hmm.
Latency, like
Sorry.
it takes a long time to connect. Latency.
So the loss is greater, sir, in this kind of communication because satellite is further away.
Latency is a factor, but that was not the main reason for dropping the major projects. Okay. The first Iridium project was dropped, but I mean, it wasn't then dropped because of latency problem. Okay. I'll discuss the rest of the slides tomorrow. Today, let me just tell you why the earliest project was dropped, or what is the key problem when you cover from the satellite. Well, from that kind of distance, your antenna gain, I mean, your coverage area cannot be too small. Okay, you are covering from a large distance. So if it depends on the antenna gain, how much area you cover, right? So from a particular satellite, when you locate towards a particular coverage area, then the coverage area cannot be too small. Okay. Then you might say that, well, the coverage area should be large. That is better. Okay. Every satellite covers a large area. Well, it's a problem with the capacity. You don't have indefinite amount of frequency. The total capacity requirement just uh, grew dramatically, requiring repetition of the frequency use. If you wanna use, I mean, just too large bandwidth is not available. You have to repeat the frequency chunks. Otherwise, you cannot fulfill the demand of capacity. So meaning that every coverage area has to be small so that the frequency reuse can be um, can have I mean, there can be more frequency reuses, or you can have more repetitions. Okay, the higher number of repetitions of the same frequency chunks you can use, the more will be the better will be the frequency and the spectrum utilization. The bandwidth requirement you can address more efficiently. Did you get my point? It's all about, I mean, in 2G, what did we see? As you increase the number of cells in a cluster, okay, sorry, as you increase as you decrease the cluster, okay, as you have more clusters in a particular geographical area, then you have higher bandwidth availability. Do you remember
Yes, sir.
a particular area, or when we use the example of board budget area? Okay, you used four. We said that first one base station we used to cover the area, then we use 4 base stations. Okay, so the same bandwidth, now we cover more users. So higher bandwidth you can support when you have repetition of the coverage areas, meaning that you need to reduce the coverage area uh, for every service from the antenna, and gradually you need to have smaller and smaller cell size, smaller and smaller cell size. That is why in 4G and 5G, you are getting smaller and smaller cells. From that large distance, you cannot indefinitely reduce the cell size. The cell size will be large. That's the problem. With terrestrial deployment, you can just keep growing. You just set up more and more base stations and reduce the cell sizes. You need even smaller cell sizes. Okay, just establish more base stations. Okay, but from, I mean, in cellular, in satellite-based deployment, you cannot keep growing. I mean, there is a limitation. You have to limit yourself somehow. That's the problem.
Because
It's the problem with the
like,
capacity.
because
Okay?
it's like we
But-
cannot just put a lot of satellites up there because like
No. That's not the point.
The point-
With a satellite, your coverage
coverage
area,
is
the antenna gain cannot be too large.
okay.
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 And there cannot be too many coverage areas.
All right.
Okay.
So there
But
will
it
be
is
like
already
yes,
10:33.
10:30.
Yeah,
So
you
we-
may have another class.
Yes,
So
we-
we'll get back to this discussion tomorrow, inshallah.
Oh,
Okay. Jazakallah.
Assalam.
Alaikum assalam.